Good afternoon. You all doing today? Okay. Well, let's get looking at next. Okay, so last time we completed looking at hold on, modules. I'm trying to get there. And I posted the video, by the way. I mean, I always post the videos, but I put it right under what we finished. So we finished looking at the structures. Yes. Yeah, and Vesper. Okay, that is exactly right. Okay, so we are done with that part. So we're going to now go to the next section, which is balancing chemical equations. When you balance a chemical equation, you are doing so that the law of conservation of mass is met. And does anybody know what the law of conservation of mass states? Oh, don't forget to put your name in the chat, please. Anybody want to volunteer that? No? Law of conservation of mass. The words should tell you. Okay, law of conservation of mass states that no mass can be created or destroyed, only conserved. So how do we know how much mass something has? Well, remember molar mass. We looked at that. We looked at how to check for that particular thing. So we did molar mass, and molar mass is simply adding all of the elements in the numbers that are found in that compound. So basically what you have to do is go to use the periodic table, right? All right, so to do that, you just look at the mass number, or the mass, the bottom, sorry, not the mass, the atomic mass for each element, and multiply it times however many elements of that there are in the particular compound that you're looking at. Okay, so now that we're talked about that, let's look at out of something, see if something is balanced. How do we know if it's balanced? Okay, let's find out. In order to know if something is balanced, we have to look at what I said. And there are two ways of doing this. They are, I like the inspection method, but there's something also called the I call it the inventory method, because it's like you're taking an inventory of what's there, kind of like what people do whenever they're looking at their cupboard or whatever. They take an inventory and write down the numbers. Well, that's what we're going to do. We're going to take down, and these should not be balanced already. Sorry, that was meant to not be balanced yet. We're supposed to be balancing it. Let me make sure there's others that aren't balanced. Yep, sure enough, there's another one. Okay, so we're gonna actually take all these off on purpose, because when we do that, we are going to, I think I saved it after I did that. Okay. All right, so what we're going to do is we're going to take an inventory of what's on the right and what's on the left. Okay, so on the left, which is known as your reactants, okay, we are going to take the numbers that are here. So we have 1 potassium, right? Just one right here, 1 atom. Here we have 2, because this is a 2 right there, 2 atoms of hydrogen and 1 of oxygen, right? Okay, let's look at the other side. We have 1 atom of potassium. The hydrogen, okay, so when they're separated like this, I like to actually call them 1 plus 2 instead of 3, because that way we know what, when we put a coefficient in front of something, it'll be the right one. Okay, so you can see everybody's balanced except for who? Hydrogen. And there are a few little rules to follow. And number 1 is you cannot play God. And since we have hydrogen here, we're going to put a 3 right there. We can't do that. We cannot change that, okay? We cannot go 3. No. Now we have something else. So no, we can't do that. That's actually a hydronium ion, and it needs a charge. So you cannot do that. The only thing we can do is put numbers in front of what's already there that multiplies that number. Okay, so one of the other rules to look at is if something has more elements than anything else, and this is this guy right here, right? We look at it first, because anything that we do to it is going to be done to all of the other elements that are contained in it. But we actually do need to do something to it. We need to put a 2 in front of it. Why is that? Because we only have 1 hydrogen here, and we have 2 hydrogens here, and this side is an even number, and we cannot have an odd number. So that means that this number is not going to change to a 2, but so is this one, and so is this one. So we just made everything out of whack. All right. So looking at that, we can see that this 2 needs to be a 2 right here, but we also have another rule. We leave the elements that are by themselves alone until the very end, because nothing is going to modify it at all. So we don't worry about it. Instead, we worry about the hydrogens that are on the right versus the hydrogens that are on the left. So we have 4 total, right? 2 plus 2 is 4 on the right, but we only have 2 on the left. So if we put a 2, that is a coefficient of 2, in front of that, that changes this to a 4, and that changes this to a 2. You see that? So now the only thing that is left is the potassium. And now we can safely balance it by putting a 2 in front of it. Now, one thing to caution you about is if everything's ending up as a 2, that means it was already balanced. but this one has a 1. And whenever you don't have a coefficient, you can just imagine there's a 1 right there, okay? Which we don't ever write in chemistry. We just do not. Just that the fact that there's an H2 means that there's 1 of them, right? Okay, so that's that one. Now let's do another balancing. Okay, let me show you how I would do it without this thing here. Okay, this is how I would do it without the inventory method. Okay, let me admit this person. I've seen her in a little bit. Okay, there we go. All right, so let's look at it. Just forget this area right here. Okay, so let's look at what I said. Always look at the most complicated one first. Okay, and then compare. So I'm comparing the hydrogen, and the oxygen is balanced. The potassium, sorry, is balanced. So the one that's not balanced is the hydrogen, because we have 2 and 1 is 3. And if we compare just directly, see, you notice I'm not doing anything on the bottom down there. I'm just looking at these. This is called the inspection method. I'm inspecting. All right, so this one needs a 2 in front of it because we cannot have an odd number when we have an even number on the other side. So now it's an even number. Now we can see that we need a 2 right here because we have 4 hydrogens. That balanced that O. And now we need another 2 for the potassium because there's 2 potassiums. See, we ended up in the same way. So I'm going to demonstrate again the inventory method with this one. Okay, so we're going to actually put the numbers in the middle, I mean the elements in the middle, and we're going to go to sodium. I'm just going to do them in order that they're found in here. And the last one is chlorine. Okay, so we got, oh, sorry, I forgot to put so. Okay, so that would have been chlorine, then sodium, and then oxygen, right? Now, let me tab it down there. Okay, and then the last one is oxygen because everybody else is already there. Okay, so that's it. All right, so let's take inventory. On the right, on the left, sorry, we have a 1 + 1 situation, right, for the hydrogen. And the reason, like I said, I like to separate them, it's because they are separate. And so whatever you do to the hydrochloric acid is not going to affect the sodium hydroxide. So we're just going to go and take an inventory on this side. Here we have 2. Okay, so that's good. Chlorines on this side, we have 1. And on this other side, on the left, on the right, we have, oops, sorry. We have also 1, right? I'm trying to make it look pretty, but it's hard. Okay, the next one is the sodium. Okay, so sodium, we have how many? Oops, sorry. Sodium, we have 1. Okay. So I'm trying to make it pretty and it's not working. Okay, so 1 sodium. There we go. Let's maybe that'll work. That's better. All right, so on the other side, we also have 1. In oxygens, we have 1 on the right. So this is where it doesn't work. Got to put the 1 and then tab it over and then move it back. See? This is where it doesn't work. Okay, and then 1 on the left, 1 on the right also. Okay, so as you can see, this is a balanced equation. Sometimes you do get those because the ratio of everybody here is 1 to 1 to 1 to 1, you know, so. And the one that is a 2 needs to be a 2. So that is amazing. It worked perfectly. So there you go. That is a balanced equation. We didn't have to touch it. Sometimes, like I said, they come that way. Now let's do this next one. Going to do the same thing. Do the potassiums in the middle. And then the other thing that we have is nitrogen, right? And the last thing that we have is oxygen. Those are our only 3 elements. Okay, let's take inventory. On this side, we have a 1. On this other side, we have a 2 plus 2. No, sorry, we have a 1. I'm looking at the oxygen, sorry. This one, we have a 1 on this one and a 1 on that one too, right? So just put a 1. On the left side, on the oxygen, here's where it's the difference. We have a 3 and we have a 2 plus 2 situation. And what did I tell you about having even and odd numbers? We can't have that. So that means this needs, and always check the one that is the most complicated one first. And that would be this guy. So we are inspecting it first. All right, so we are looking at it. And you see, there's a 3 right there. That 3 and the other side is both of them are even. So you can't have an odd number. We need to put a 2 in front of that one, which makes this a 2, which makes this a 2, and makes this a 6. Yes? Because 2 times 3 is 6. On the right side now, we have to inspect. Okay, so we need to definitely put a 2 in front of this, right? Because we need 2 potassiums. So 2 potassiums are there. Now we have 2 nitrogens, and we have a 2 times 2 situation. And there you go. It's balanced. You see that? So that's one way of doing it. The other way, like I said, is not paying attention to any of those things and just looking at the elements themselves. And that's the inventory. That's the inventory. The one I like to do, and I'll do that later, is the inspection method. All right, this one right here, we have carbon, we have hydrogen, and we really don't have much. And we have oxygen, and that's it. Okay, so let's take inventory on the right one. The right one has a 2 carbon thing, right? The left one has, oh, that's a little far away, but a 1 carbon on that side. Okay, so let's tap this one over and bring this one back because I don't like it. Oops. Sorry. There, that's better. All right, on the right on this side, we have 2 hydrogens and 2 on the left, right? 2 and 2. On the left here, we have 2 oxygens, and we have not 2. We have a 2 plus 1 situation. Okay, so the most complicated one of these, you could take it as the carbon or but I would say it's this one because it has more atoms itself, right? So I'm going to compare everybody else to it. All right. Well, I'm seeing the carbon is definitely not balanced. So if I put a 2 in front of this, right, that's going to become a 4. So that means this needs to be a 4. Oh, sorry. See, this is where I digress with this one. Okay, and that needs to be a 4. Okay, so now if I put a 4 on that one, that's a 4, right? This hydrogen doesn't get affected, but the oxygen does. The oxygen is now an 8, is it not? Because 4 times 2 is 8. All right. So that worked there. Now look who's not balanced. Hydrogen. Okay, so it's obvious we need to put a 2 in front of this guy. And that changes this to 2. No, to 4, sorry. And then the oxygen on the 1 is changed to a 2. See there? And that's how many hydrogens. That's a total of 10, right? All right, so on the right, we only have 5. So what number we only have 2. There I go, I already answered it. What number do we multiply the O2 times to get 10? All right, so we need a 5, right? So we put a 5 right there, and that changes to 10. And now everybody's balanced. You see that? Okay, so this is one way of doing it. Like I said, this is the part that I think it's okay for you guys to start this way, but don't keep this way because it takes a lot longer. And you also have to be very careful not to forget to change something that you wrote in your inventory. Okay, that's the picky part about this one. Okay, Hori. Got another sneeze coming. Okay, always when weather changes, I sneeze. Okay, so let's go. All right, let's check. Carbon, oops, sorry, carbon. We have hydrogen. And we have oxygen, and that is, again, all we have. And this looks like a very complicated reaction, doesn't it? And it is. You would be correct in assuming it is. It is. All right, so let's take inventory. Oops, and this one's already balanced. I didn't even notice that. Not supposed to be balanced. We're supposed to reach these numbers. I thought I had taken all of them already, but I didn't do this one. Okay, so this one, we have an inventory to take. So it's 4, oops, 4 over here. Accidentally hit that going down. And a 1 over here, right? On this side, the hydrogens, we have 8. And on this side, we have 2. On this side, we have 2 oxygens. And on this right side, we have a 2 + 1 situation, right? Because we have 2 from the carbon dioxide and 1 from the water, right? So we can really see that everything's messed up. The most complicated one, so like I said, the one that we always look at first is the one that has the most atoms. So I would look at that guy first and compare. All right, so carbon's definitely not balanced, so let's do that. All right, so there's 4 here and there's only 1 there. So we can put a 4 in front of this one. Sorry, I'm trying to let somebody in. Okay, so we put a 4 in front of this one, and that gives us 4 here. But it also changes our oxygen. 4 times 2 is 8. Yes? All right. So now we have hydrogen to do. Here we have 8. Here we have 2. Not quite. So we need a 4 in front of that one. And that gives us 8 on this one. And 4 times 1 is 4 on this one. See, now everything is balanced except for the oxygen. And that was the other rule that I told you. You leave the elements that are alone, as in uncombined, and I'm going to write it in blue. So those are to be left alone until the very end. Why is that? Because they don't affect anybody else. But look how all of these other things changed. So if you had started by balancing this side on the oxygen on the left, you would have screwed up everything and it would have taken you forever. Whereas following that rule of leaving the one that I just highlighted in blue alone, which is an uncombined element, then we can just multiply it by whatever it is that we ended up with in oxygens. So A + 4 is 12 divided by 2, right, is 6. So we need a 6 right there, and that becomes 12. And there you go. See? So that is a balanced reaction now. Okay, so let's do one more, and then we're going to go 2 more. Sorry, 2 more. And then we're going to go and do another one. Okay, so this one looks very easy at first. Okay, so you got mercury and you got oxygen, and that's all you got. All right, so on the left, sorry, we have 1. On the right, we also have 1 mercury. On the left, we have 2 oxygens. On the right, we only have 1. So this is the most complicated one first, yes? because it is the one that has the most atoms that are combined to each other that are different also. So most atoms and also more different ones, if that is at all possible. All right, so we're looking at it, we're comparing. Okay, so there's 2 oxygens, so we need a 2 in front of it. There's no doubt. All right, so we put a 2, that modifies this as a 2, that modifies this as a 2. And now look what's left. Just put a 2 in front of this one, right? And then that becomes a 2. And now we have a balanced reaction again. All right, and let me bring these up because that home is in the way. Okay, so now, all right, let's take an inventory of these guys and see what we get. All right, sodium is our, no, sorry, silver. I always try to do it in order from right to left. And I think, yeah, I think for some reason this is smaller, but it doesn't matter. All right, so now we've got nitrogen. Then we have oxygen. And then we have sodium, and that's in chlorine. Oh, there's a lot of elements in this one, isn't there? Let's make it higher so we can do, we don't have to go underground here to get this last one. Okay, so the last one is chlorine, right? All right, there you go. All right, let's check and see how many we've got. See, I think that is what's going on, but that's all right. We have 1 on this side. Oops, and we have 1 on that side. Always start with the left because I'm, 1 on this side too. See, that's what I said. That is weird. And we have a 1 on that side also for nitrogen. So far, so good, right? We have 3 on this side on the oxygen and 3 on this side on the oxygen. We have a 1 on this side for the sodium and 1 on this side also. And the chlorine, we also have 1 and 1. And this right here is a balanced reaction. As you can see, it is already balanced. Now, another tip that I can give you, and you need to look at, is that if you have a polyatomic ion, and I'm going to use the other color. So if you have a polyatomic ion, such as nitrate, that remains the same, like it doesn't break up during the whole reaction, then this right here is pretty much annoying. Instead of doing what we did here, oops, I'm sorry, I need to erase that. No, not that, this right here. Come on, let me erase you. Okay, and I'm going to show you what you would do instead. It is a better choice, and that is what I would do. Is I would call it one group because it is an NO3. So that's the group. And it is a group because it's nitrate. So we have 1 nitrate on this side and 1 nitrate on this side. You see that? And that makes it a little faster for you. At some point, you will see that. Right now, you're not, because this is an easy reaction. And there aren't any others that we actually could use that way on this one, except for OH, and OH broke up. So nope, can't do that one. This NO3 broke up. So nope. See, this is why I didn't show you this one trick. All right, so let's go to another one. And let's look at that one. Right, so that was an example of how to do balancing of this kind. Now let's go back to another one. And there are some practice in here. Okay, so we are going to, oops, don't go too far. Sorry. Where did you go? Okay, we're almost done. All right, there, this one. Okay. And then there's a tutorial that you need to look at on your own. And this is all the tips that I've been giving you. They're in there. So just, that's like a summary for you. All right, so I said download and it didn't download. Come on, open. There we go. That's what I need. All right. So, come on, open up. All right. So for this one, we're going to do the same thing, except I'm not doing that method anymore. I'm doing my method. Okay. And my method is the inspection method. You want to copy the equation and put all the elements below it, that's fine with me. You do it your way, I do it the way that I'm showing you right now. Okay, so I'm saying I am going to highlight the one that is more complicated, and I'm going to compare. Okay, so the H3 is definitely not balanced, so we are definitely going to need this to be balanced to that. Now, since this is an odd number, doesn't matter how many things I do to this one, it is never going to balance until I actually balance, make this one an even number. So there's my even number. So 2 times 3 is 6, right? So we just need a 3 in front of that, and we have a balanced reaction. You see that? Without the inventory. Because now you have 2 nitrogens, which are 2 right here, and 6 hydrogens, which you have 6 right there too. All right, let's look at this one. Again, I would look at this one because this is my most complicated one and compare. Once again, we have the even odd situation, so definitely need to put a 2 in front of that. If we put a 2 in front of that, we also need a 2 in front of this. And then now we have the oxygen to balance, which is 2 times 3 is 6. So we just need a 3 right there. And there we are, balanced. See, this goes much faster when you just compare. All right, and also when you have a little practice, obviously. All right, out of these two, it doesn't matter which one you pick. They're all going to be the one that you want to use. So let's just use this one just to have something to start with. All right, so if we compare, we can see the sodium's balanced, but the chlorine's not. So we need a 2 in front of that. Now the sodium's not balanced, so we need a 2 in front of this. And now everybody's balanced. Do you see that? Pretty simple. You could have started with putting the 2 in front of that. It would have been the same thing. All right, let's look at this one. Here's what I was telling you. Okay, so I'm going to highlight the group that ended up being the same on both sides. Okay, see? And now you can really see a course of action a little bit easier. All right. So I would start with magnesium nitrate because, and I'm going to re-highlight it again because it is the most complicated. Now this part right here, I re-highlight again, twice, because this is the part that we were talking about that we need to look at it as a group, remember? Okay, so on the right, we have 2, right? 2 nitrates. On the left, we have 1. So we know to put a 2 in front of that one. Now the nitrates are balanced. Now the silver is not balanced. And we need a 2 in front of that. And look, that balanced everybody else. You see? Okay. I would say the most complicated one is the aluminum sulfate. But we also have sulfate. So sulfate here, right, is going to be the one we're going to concentrate on as a one group. So again, I'm going to re-highlight this sulfate by itself. just so that you see that that's the next part. Okay, so let's look at it. Most complicated one being the one that's in yellow with green. All right, so looking at it, we can see that aluminum is now balanced. So we're going to need a 2 in front of, oops, I don't need highlight anymore. I just need my typing. Okay, nope, no more highlight, no more color. Nope, just typing. Thank you. All right, so right here, we're going to need a 2 in front of that. All right, that makes how many bromines? 6, right? So let's put a 6 right here. So 6 potassiums, 6 bromines, not balanced anymore. The bromine is, but the potassium's not. So we need a 3 in front of that. And look, now we have 3 sulfates, 6 potassiums on this side, on the right and on the left, both. Let me see, when I say 6, I should just be pointing. See, 6 potassiums, and 3 times 2 is 6. We have 3 sulfates, because this is multiplying all of that. So that's 3 sulfates and 2 aluminum. So everybody's balanced, you see? All right, let's do another one right here. Okay, so obviously, my most complicated one I'm looking at is definitely this hydrocarbon right here, because it has a total of 26 atoms. That's a lot of atoms to balance. All right, so comparing, right? Looking at it, I'm gonna compare. So you have 8 carbons, and here you only have 1. So let's put an 8 in front of it, right? That gives us 8. And we have 18 hydrogens, and here we only have 2, so we put a 9 in front of it. All right, that gives me a balanced equation pretty much, except for the oxygen. All right, so oxygen, and I'm going to write up here the number that I'm going to be writing as far as how many oxygens there are. Okay, so oxygens, 8 times 2 is 16, right? Plus, on this one, we have 9. And that gives me a total of 25. But 25 is not divisible by 2 unless we put 12.5 right here, right? And we cannot have, and yes, I know that you sometimes see reactions balanced like that, but that is incorrect balancing. They actually all what do you call them? All coefficients need to be whole numbers. So the solution here is to double everyone. So this becomes a 2. This becomes a 25. This becomes a 16. And this becomes an 18. Right? And now everybody's balanced. And if you add let's see. $16 times 2 is 32. That's not going to work. Yeah, that is 50 total, right? So 50 minus, so that is going to be equal to 32 plus 18. Is that correct? See? So that is exactly the balancing of the oxygens. So that's one thing you can always do if you end up with an odd number, or you can do what I do on this particular kind of equation, which is known as a combustion reaction of hydrocarbons, which we will learn here soon. When you have a combustion reaction of hydrocarbons, always check the hydrogens. The reason I check the hydrogens is because they're going to come on this area, and that is multiplying an oxygen. The oxygen needs to be even because, well, oxygen is always O2. Therefore, the number that you end up with has to be even. So when you check this right here, you divide it by 2 because you have 2 already here, right? So if the number that you get is an odd number, which 18 divided by 2 is 9, then I would just start by doubling everybody to begin with. So how do we do that? Okay, so let's start again. And let me show you how I would do this. All right, so I look at my hydrogen. I say, okay, hydrogen, that hydrogen divided by 2 is 9. Therefore, I need a 2 right here. That 2 made this 16. That 16 made this 18, right? And now everything works with the 25 right there. See? So it's much faster. You don't have to go back and double everybody if you pre-check. I like pre-checking. A lot of things I pre-check myself. All right, so there you go. All right, so let's do this next one. Okay, most complicated one would be the one I'm going to highlight, which is the P2O5, right? So we compare everybody to it. You notice that there's a 5, and this O is a 2. So we cannot do that, cannot do the odd even thing. So we must make this an even number, which gives me 4 phosphorus, right? And 5 oxygens. And there you go. Everybody's balanced now. Okay, let's look at this guy. I would start with this one first, the silver oxide, and look at it. All right. Silver, we have 2 here. We only have 1 there. We have 1 oxygen here. We have 2 there. So we need a 2 in front of it. You notice I didn't start with the silver. Why? Because the oxygen here is odd numbered. The one here is even numbered. Always check those 2. The oxygens, if they're odd and even, you got to double the odd, so that it meets the even eventually. All right, so we got 4 right here. And that's it. We're balanced. Again, we have 1 more, last one. Okay, so this one is with those groups. Remember, we said that we are going to treat the entire group like we did over here, right, as 1. All right, so we're going to do this one. This nitrate and this nitrate treated as one thing. And we also have hydroxide, so I'm going to have to use a 3rd color. All right, let's use pink for the hydroxide. Hydroxide here is pink, and hydroxide here is 3 of them, okay? So, you see that? If we just treat these as 1, it's very quick to balance. All right, so which one's the most complicated? I'd say the first one, so we're going to highlight it as the one we need to start with, okay? And again, let's re-highlight this nitrate like we did before. Okay, there we go. Okay, there we go. All right, so let's look at it. Okay, so we're looking at aluminum. Aluminum is balanced, but nitrate is not. We have 3 nitrates on the left. We have 1 on the right, so we put a 3 there. Now we have 3 sodiums, so we need a 3 in front of this sodium. And look, everybody's balanced now. You see how if you treat everybody as 1, if you had done the whole inventory with oxygens, hydrogens, you would have had to do a 6, let's see, a 9 plus 3 on the right. I mean, it would have been a mess. It would have been a mess. You couldn't have done that. So you got to use this as groups. So that's the other tip. If you have a polyatomic ion that stays untouched throughout the whole reaction, as both of these did, then treat it as one thing. So another thing is also known as the X-wide method. So basically, let me show you what that means, and then we'll be done. So we have rewritten our equation. I'm going to rewrite it as aluminum X3. X meaning one thing, so that you don't, that way you don't focus on that thing. And Na, oops, Why is it doing that? NA, look at this thing. It's being very annoying. Clear that. Okay, so NA, it's not letting me. Okay, let me try it with this thing, the text. Let me do it this way. Yeah, I'll just redo it like that. So aluminum X3, and it's doing white, so of course you can't see it. Let me do it in black. There we go. Plus NaY, right? Because it was just one. Yields Al Y3 plus NaX. So see, it's quite obvious when you look at this how to do the math. See, you see the Y3, you know there's a Y, so you need a 3 in front of that one. You see the X, there's an X3, so you need a 3 in front of that one. And that's it. Makes it much faster and easier to do. And then, of course, once you've already done that, you can just transfer the coefficients where they belong in your actual equation, like I did, which is the 3 over here, right? Oops, sorry. Highlighting. I'm trying to highlight and it went away from me. Come on, you. Go away. Okay. Let's highlight it in blue so it'll be a totally different number. So this 3, highlight, and then this 3. See? They come from this area right here, which I can't highlight because it won't let me. But that's how you would do it. Okay, so next time we look at types of chemical equations. So practice your balancing skills. Make sure that you look through the very nice tutorial on how to balance, which is found right here, like I showed you earlier. Let me see. Oh, I need to erase that thing. Okay, which is found right here. Hold on, let me go back out of this. Right here in the tutorial here. It'll say equation tutorial. Right there. See it? Oh, sorry. Balancing chemical equations tutorial. It will not allow me to show it to you. It keeps moving. Okay. Right there. Okay, just download it, look through it, read it. Practice, do the few balancings that are on there based on what they're asking you, because you are definitely going to need to do balancing. And see, there are a couple of them right at the end. They've got the blanks for you, see, for you to actually balance them. All right, and that's it. I will talk to you Friday. You guys take care. And I will be posting this lecture soon. Oh, and
Thank you,
before
Ms.
you
Vides.
leave, if you haven't done it, put your name on the chat because that's my attendance. Okay?
Ms. Vides, question, right?
Yes.
Sorry. Yesterday you had a bonus.
Yes. Did you like
The
it? Was it
Halloween
fun?
bonus. Unfortunately, I didn't have the materials to do the
Oh, you can still do it. It's open.
But I still did it by like explaining what I saw and.
Okay, basically what you had to do was repeat the thing and just videotape the reaction that you created, the delayed reactions, and that's it. That was it.
Okay, well, all right. I think I did that.
Let me go to the mod to the since it is time for class for the other class, we can stay if you have time.
Yeah, I do.
I'm fine with that. I have no problem. Let me go.
Thank you.
Sure. hold on. Let me just stop this share first, because this is what's driving me crazy. All right, there we go. No, I'm not ending the meeting. I'm just ending the share because I can't work with it if I'm sharing. It won't let me. Okay, so let me go to your Wiley. There we go. Go to Canvas. And I'll share again in a minute. Let me just get ready and do the bonus. The bonus, I just had it. I thought it would be fun to do because it is a Halloween colors and all that stuff. And also gives you something else to do and also have fun at the same time. Okay, so here we go. It is on. I can share now. Okay. So basically you just watch this video, right? And complete the reaction in it. And the amounts of reactions are provided in the video. And then you just take a video of those results and put yourself in the background, because otherwise people can share this video and everybody will have a video. You see what I'm saying? Without you being in it, then everybody can be this video. So that's why I put yourself in the background. So basically, like this guy did, you know, they didn't show themselves, you would have to show yourself just before you dump it in or something.
Okay.
Something, that's it. So in order to follow, let me see. We're just gonna go to where it starts. Okay. Okay, that's step 8. That's too many. That's too many steps. Okay, hold on. Go away. Okay, I said allow them. Oh, refresh, whatever. Sorry, I have to refresh it because it's just not letting me look at it otherwise. All right, this is just a preview, but it goes step by step. It tells you how to do it. Okay, so number 1. And by the way, okay, see, you can just, every time that you see a step, stop it and write it down. And it would be best if they're clear cups, right? So that you can actually see the reaction going on. So use however many clear cups you want. You don't have to use 5 if you don't want to. You can just use 3, you know, just so that the delays, it's fine. But if you want to do it just like that, there it tells you 10 milliliters or 2 teaspoons of hydrogen peroxide, which you buy at the store, probably $1 each. And you could probably do it as a group. You know, that's something I should have done. I should have done it as a group so that the cost would be reduced. You know, should I do that? The Monday group and the Wednesday group? What do you think? Did you leave me? Jean-Marie. Can you hear me? Can anybody hear me? That's the thing. Ah, that might be it. No, I'm not muted. What's going on? So basically it's 2 teaspoons of 3% hydrogen peroxide. And you have 5 cups.
Oh, Miss Vidas, my bad. I was responding to the personal trainer.
Oh, okay. No, that's fine. I just making sure that you're still around because I was telling you that.
Yes, I'm still here.
Okay, so basically, what do you think? Should I put it as a, since it's all these materials and they do cost?
Yeah,
Let's do it as
why I was
a whole group, a whole class group, like Monday group and Wednesday group.
Okay.
and have
So
everybody in the video.
okay.
How's that?
So we go. So do we do it in person?
Yeah.
In the lab?
Yeah, you could do it in the lab if you want, or you can do it at home. This is all stuff you can buy at home, and it won't kill you or anything. It'll be, you know, just stuff you can throw down the drain. But you could do it in the lab. Yep, you sure could.
The
I
other
don't
thing is that
think I have
okay.
anything in the lab except vinegar. I do have vinegar in the lab, so you don't have to buy vinegar. Okay, so see, that's step one, right? All right, so I'm just reading you. I'm stopping at every step so that you can read the directions. Okay, there's step two. See 1 drop of red, and 1 drop of yellow food coloring. All right, to each cup. And then half a cup. You see that? It's telling you exactly what to do. Of vinegar. And I do have vinegar in the lab. There should be a few vials of white vinegar there. Okay, so that's step two. So let me see. See? And then this is the next step. That's the half a cup. All right, now, the next one is 10 drops of starch. Okay, so basically you're gonna need 2.5 cups of vinegar, right?
Did you want to open your car?
Yeah. Okay. And then the next one, drop, drop, drop. See, that's it. Then step 5, stop it, and it's 1 milliliter or 20 drops, 1 milliliter. So, and you notice it's a certain type of iodine. Can't be tincture of iodine, that won't work. This is iodide's tincture. Which has no color. That's the difference. Okay. All right. There's several steps, but they're pretty easy. All you gotta do is drop, drop, drop. Okay, there you go. This is the next step, is to add half a teaspoon, 1.5 teaspoons of fruit fresh to 100 milliliters of water, or a half a cup of water. So you're making a solution of this stuff. And then once you've made that solution,
They took this paper that I had. Yeah. You don't want to share?
you need to add different amounts. And this is where it goes. That's where it goes to cup 1,
Don't.
2, cup 3,
That's right.
cup 4, cup 5, right? So they're all different. The very first one, you're going to add, and the small cups don't have to be clear. You're going to add 5 drops to the first one, 8 to the second one, 13 if I'm not mistaken. No, 10, then 13. And then I think it is 16, the last one. Yeah. And that's how you get the reaction delay. Okay. And that's it. And then just pour them in. And if you have 5 people, you can all pour them in at once, right? So you don't have to do this part if you're not alone. And then videotape that right there. This is what I want. I want you to videotape this right here, working just like that. And you can put yourselves in the background, everybody that participated. Make sense?
This you're gonna change it today?
Oh yeah, I am.
Okay.
I had not put it. If you notice, it's, let me see. I'm going to show you what I did. It's actually turned, you can turn it in at any time up to, let's see, when is it due? See, November 6th is when I left it up until, but I'll put it for November 6th here. How's that? And that's Friday, right? That's in a week.
Okay.
And leave it for November, all the way up until November 12th even, okay? There. Not October 6th, November 6th. Sorry. That's actually, that be in a week is 9, 8, 9. Because that would have been Monday. All right, there you go. So you have a week to get it together and do it. Does that make sense?
Yep.
And
Thank
you guys
you.
can do it as a group. And I'm going to put that on there. I'm going to actually edit it. And
Oh my goodness, it's a school bro.
you can use it as a group as long as you're put yourself in the background.
And then I saw that the week of finals, so that's the like a lot of stuff is due. So I was gonna make sure that before I do them, I don't like, some teachers will like take away some stuff that unnecessary. And
Mm-hmm.
I don't know if you understood the question, but on I'm not sure the exact date, but it had a whole lot of stuff due for chemistry labs and like general class.
Oh
Yeah.
yeah, I know what you mean.
Yeah.
I'm
So I was gonna before I do them, I wanted to make sure that it is mandatory to
there.
do it.
How's that? Is that clear right there? Can you
Okay,
read it? Oops, sorry, I'm making it too big. There you go. Can you read? Oh man, it's still doing that. Why are you doing that? There we go. Can you read that?
Yes, it is. It's clear.
Right there.
Okay, that's it. All right. Okay, so we are pretty much almost done. It doesn't look like it because I know there's a lot of stuff, but I like to separate topics, and a lot of the times the topics just kind of go together. So like today, the topics really go together, but I separate them on purpose so that you grasp the first one without having to worry about the second one. The second one is usually very quick and easy. It's kind of like when we did that Lewis structure and then just did the intermolecular forces at the very end very quickly. Yeah, kind of like that. It's the same thing. Oops, sorry, the wrong one. And let's see, I thought I had you on there, but I don't. Right. So basically there is okay, so hold on. once I'm talking, if I'm clicking, I can't talk because then I'll click the wrong thing. If I'm trying to concentrate on what to click. Okay, here we go, modules. All right, so next time, and that is Monday, right? We will be looking at this right here. Okay, we are looking at this, the types of reactions, which is very quick. And then the last thing we have is acids and bases and moles. Acids and mole is a little bit more complicated, but it's easy enough that you can do it. And then you've got acids and bases, which is pretty easy also. And then you've got your final exam. And you notice that you've got a review.
Doors on the bus, go open and shut. Open and shut.
Okay, so you've got
Anaya.
a review right here. This is review part 1. This is the review I will be going over during the week of finals. Okay. See, this whole entire thing, I will be going not over the whole entire thing. I'll just pick a few of them to do. Yeah, exactly. That's all of those. Okay. And then I also have the second part. And this is the one that, like I said, I go over most of it, and you guys can be taking the, you know, you can probably watch the video after I'm done too, because that's one of the things that I do. Okay, and then this is the part 2 right here. Hold on, get it in a minute. This is part 2. Okay, now I suggest that when you do your turning in, see, now this one is a little different. It covers different stuff from the other one, but this is not the math part. The math part's the hard part for most people, then they want to remember it. This part right here is something that you can just find easily, pretty much. See? And it's more of a second part of the study guide, but this one you can do on your own, basically. Easily see there's the 5 types of reactions, classify and balance. And then these are acids and bases, and basically that's it. And there's some definitions. And these are, put the definitions on there because they're important for you, because you will have some questions on the test that will ask you some of that. And basically that's all of it. That's the whole entire thing. If you do this part and you turn it in and it's pretty much complete, you will earn 15 bonus points. With the first part, since I do the majority of it and it's more complicated, you earn 10 bonus points if you finish it. Okay. Keeps doing that. That's annoying. Why does it keep doing that? Which is not what I want. It's so crazy. Okay, here we go. And the final exam is long. I will warn you against that. Because it is covering everything. And the reason it covers everything is you will see, you will have to know every single thing that we are doing.
So like 100 questions?
Exactly.
Oh my Lord.
But a lot of them are very fast. I mean,
Okay.
I can show you some of them just so that you'll feel at ease. See, look, just a real quick look, okay? Real quick look. I'm not showing you all of them. Pick the numbers you want to see.
Number 20.
Number 20, okay? Okay, well, there's this question 1. See how easy that one is?
Yeah. Oh, I get a question like this.
Yeah, exactly. And you said 20. Okay, you want to see number 20, okay? So there's 20. See? In scientific notation, 8.329 times 10 to the 3rd. You see that? Easy. Okay, next, another question you want to look at. Just pick another one. You're seeing 2. You're getting a bonus.
35.
35? Okay,
Yes.
let's look for 35 next. All right, 35. All right, ooh, one more. There we go. Question 35. There's question 35. How many neutrons and protons? You see that? Pretty easy, right?
Oh, it's not a bad.
Yeah, that's what I was telling you. It's not
It's similar to
complicated.
the test that we got in the past, just combined.
Yes, exactly. It's like all
Okay.
of exactly. Pick another one, another 2 or 3, and I'll show them to you. So you'll feel good.
87.
87. Okay, well, that was a weird number. Okay, there you go. Now, this one you haven't seen yet. So, of course, this one's going to look complicated to you. But basically, this is a synthesis reaction. Okay, so that would be your answer right there. Boom. That's it. See how hard that was? All right, something else? You want to look at the last one? Question 100?
Yeah. Yeah.
All right, let's look at question 100. Which of the following are matched incorrectly? Polar, non-polar, tetrahedral. Okay. So definitely water is polar. So that one is not a correct.
Not correct.
This has a that does have a tetrahedral electron pair geometry, has a bond angle of 120. That is incorrect. It is 180 because it's linear. And that one has 2 resonance structures. You would have to do the actual Lewis structure. I do it really fast in my head, you know, because I can do that. But basically it's 5 and 16, that's 21, so it's 20. So it does have a resonance structure. Yes, it does. And then SO2 has a trigonal planar. Yep, those are. So this is, so that's a true story. And does this one have a trigonal planar molecular shape? No, it does not. And it's very obvious that it doesn't. Why? Because it says molecular shape, and a molecular shape would include, yeah, exactly. You would have to have an SO3 at least, right? Because a molecular shape would have to be all of bonds. And you cannot have a molecular shape with one of these, which is why it's SO2. It's obvious that it has a lone pair to me, or that it's a linear, either one. It can't be what it says. Okay. So that's it. So there you go. See, they're not so bad, right? Anaya, did you have a question too? I saw you had it.
Yes, I had the question about the lab that we had to do. The one
Which
with
one?
the remember when it said to redo the experiment, but we didn't have materials, and I didn't understand how you were explaining it to John Marie. I was gonna actually explain it again.
Okay, sure. Be glad to. All right, let me go back to, I'm showing you the whole entire final exam. Don't want to do that. Not the whole thing. All right, so let me go back to it. All right, so basically what you're going to do, right, is you're going to watch the video and stop each step, which is what I did when I did this one, when I looked at it. So right here, right, this is a Halloween clock reaction. That's the one you're talking about, right? The bonus. Okay, so basically you watch, that is the one? Okay, so you're watching the whole video and you notice I changed it a little bit. Oh, look, I changed it and it didn't save. Oh man, I have to change it again. Okay, so take a video of the results. Okay, I have put on here that you could do this as a group. What on earth happened? Everything I say,
But where would we get the materials from to do it?
you would have to purchase them. And that's one of the reasons why I said that I do have vinegar in the lab though. I do have vinegar. I don't have hydrogen peroxide.
The only thing is that well, for me, I don't have it like that.
Okay, like if you go to like, let's say Walmart.
Like to purchase stuff, because I have to pay stuff 10 times, but not 10 times, 7 times our money.
Right. And that's why I'm trying to show you like how much they are. Like if we're looking for iodide's tincture, right? Let's see, can we look for something right here? This might be the most, see, decolorized. That's what you want.
And then the next problem with this too is
Okay,
that we don't
so
have
you don't have to buy the more expensive, obviously. You buy the $6.95 one, right?
Miss Days. I think the problem with this is that because we don't meet again in person, so we the class, like, we don't have each other's contact like that.
Right.
So I think is you can like replace another bonus point. 'Cause I know they're not gonna meet.
You're not going to be able to?
I know they're not gonna meet.
You know they're not.
I know that for a fact.
Ah, that's too bad, because that would have been a good one to do for you. That, you know, because whatever, I was trying to find something that was different and it was easily doable for you as a non-science person, that you could just go and buy these things somewhere else. And this is one of the ones. See, you don't need but one fluid ounce. So if you were to buy that, that would be one of the things. I know it says $7. I'm just showing you. And then Fruit Fresh, and this would not be at Walmart. Let's just say you're just going to go to Household Essentials, maybe. I don't know. Let's try and see if we can find Fruit Fresh on here. Yeah, see, Fruit Fresh, not fresh fruit, Fruit Fresh. Basically, Fruit Fresh, all it is, there it is. It said, did you see it? It said canning product. There it is right there, Fruit Fresh. Not mixed Fruit Fresh. Just Fruit Fresh. There it is for canning. See? That one is cheap. That also, it's like $3.70s. See, you don't need a whole lot. They had a big one, but you could buy the smaller one and that would be $4. So that's so far, that's tens. Like I said, you can see if anybody wants to join with you and buy the few things, because the other things are cheap. Hydrogen peroxide, you can go to like Dollar General and you can buy a whole thing of for $1.25. What is the other thing that we needed? Food coloring. Does anybody have food coloring at all? Because I mean, like if you cook or whatever, you have food coloring. You already, all you need is 1 drop of each. And let's see what else we got.
I don't know.
That's about it. The rest is water. Yeah, that's it. That's the most expensive part right there. Let's see. Yeah, basically vinegar is cheap too. And I have some, oh, the starch. But actually, you know that you can use cornstarch also, right? You don't have to use the starch that they're talking about. You can actually use cornstarch, because cornstarch will turn black also. And you can make a solution yourself. And cornstarch is
I
cheap.
could probably ask Dr. Ghost, because I know for a fact I can't spend money like that, especially this month, because I already paid to go home and everything is expensive.
I'm just looking at how much cornstarch is. Cornstarch is, see, look, it's $1 or something. or this, oh, this is corn syrup, $1.82. Yeah. And what was the name of the starch? Stay Fresh, was it Stay? What was the name of it? Starch solution. It's for laundry starch, I think is what they call it. No, that's the wrong one. Oh yeah, no, that's the wrong one. I think it's called laundry fresh, laundry starch. Okay, that's what it's called. Yeah, there it is, Stay Flow. See, it's cheap. Also, like I said, I know it's not what you need, but that's what I thought it would be cheap. But I mean, I would have loved to have done this in person, you know? But unfortunately, with my car, I still don't even have a loaner. They're not giving me a loaner at all. Not even, unfortunately. So I don't know when my car's gonna even be ready. This is not fun because I normally would have gone somewhere by now. Yeah, see, you can get more expensive stuff, but you can also get cheaper stuff. Starch alternative. You don't want that. You need starch. You need actual starch. Cornstarch will make you a really nice solution too. Try to see if Dr. Gorski has those things, and you can do it in the lab. She probably does have vinegar. She might even have cornstarch, because if she does what I used to do with the chewing of the cracker for biology to show the digestion starting, that's one of the things. And just use iodide directly on it and it turns black. She probably has some hydrogen peroxide. She should have that. Let's see what else we got. Hydrogen peroxide. We have a vitamin C tablet would be really all you would need for ascorbic acid. You don't really need fruit fresh if you can't find it. You could just use a vitamin C tablet. And, you know, those, they come in, I mean, somebody takes vitamin C, I'm sure. Because ascorbic acid is vitamin C. Let's see what else we got. We got, let's see, we had hydrogen peroxide, that's cheap. And it's available, I think. She might have the colors, you know? She might have the red and yellow food coloring. The vinegar, the starch, you can just use cornstarch. And the iodized tincture is the only thing that you would have to actually purchase, because that I don't have anywhere. I don't have anything like that anywhere else. And vitamin C, I even have vitamin C. I take vitamin C myself. So all you would have to do is crush it and make a solution with it. So, okay. I understand that you guys, well, I mean, it is a bonus. It's not like a necessity, right?